Hello everyone. Good afternoon. My name is Bruno Borges. I'm from Microsoft.
Hello, I'm John Oliver, also from Microsoft.
I'm from Canada, and you are?
Sorry?
I'm from Canada. You are?
Oh, hi, I'm from UK.
That's the only thing we have in common. The king, not the queen anymore. So this talk is about RPG assistant. It's about game masters who operate and run a game like Dungeons and Dragons and other games like that. Who here has ever played Dungeons and Dragons? I wonder why you're in this session. Who here does game mastering? Wow, cool, interesting. Who hates doing game mastering? Also interesting. So maybe you will hate less with what we have to show. So the agenda for the next 30 minutes, we're going to show the RPG assistant, and then we're going to talk briefly about how we implemented the code. Well, actually, mostly John, how he implemented the code using a project that Microsoft created recently called the Semantic Kernel. Semantic Kernel is a set of libraries in different languages, Python, .NET, Java, and coming soon TypeScript. And it's more than an OpenAI SDK. It's more than just an OpenAI REST API wrapper. It has a lot of other features, and it really helps you create intelligent applications. So we basically call Semantic Kernel an intelligent application framework. And we're going to walk through some of these capabilities as John walks through the code. And with that, hopefully, we'll have a lot of curiosity about Semantic Kernel. And also in trying the RPG Assistant, which is open source and available on GitHub. The only thing that you will need is, of course, an OpenAI credential. And you can go to platform.openai.com, or you can also use Azure OpenAI. And in the future, hopefully, the Semantic Kernel will also support other models and other services because it's an open source project, and we are, of course, receiving pull requests and contributions. So the Forgetful Game Master app is very simple UI, but as a game master, you record what's going on with the players, and you record what actions they are taking, and then we start recording all the stats of those characters. There is a feature for generating a character. There is a feature for setting the rules and some admin features. And behind the scenes, we have used Quarkus, pretty much the latest version. The UI is React. The endpoints are just RESTful endpoints with JOXRS. We do use the Microsoft build of OpenJDK 21 during the demo, and the Semantic Kernel. And that's the URL for the code on GitHub. So before we dive into the code, briefly, what is a Semantic Kernel? This library contains several components. But basically, it gives you the ability to abstract not just the prompts, but also the skills, the capabilities, and the memories that your application may need to execute those prompts. And you can combine user prompts with system prompts together with a template engine that you can get data from the user or from the system and inject that automatically into the prompt that goes to OpenAI. And we parse that result, and we give you the data in a way that your application will understand. More about Semantic Kernel on Thursday session. Here's the QR code that you can just scan and go straight to the session on the DevOps schedule on your browser. And then you're going to dive into details about the API. So for the next 25 minutes, John will walk through the code for the RPG Assistant, and as he shows you, demonstrates the application, you'll have a good understanding of the capabilities of Semantic Kernel, and also how you can potentially integrate those capabilities into your applications as well. All right, John, it's with you. I did my PowerPoint session. Now the code is yours.
Yeah. Okay, so where is the UI? Okay, excellent. So, I say it's an application for helping GMs run their games. So it's a React front end talking to a Java backend that's running the semantic kernel. So here we have the ability to select characters that are in our world. Okay. So. Aha. Okay. Right. Thank you. Yeah, we got the ability to select characters within the world, and associated with the characters will be sort of facts, things that have happened to them, and just general information about them. We have sort of the usual stats of a character and inventory. Then we have a player log, which is events that have happened to that specific player. And then we have a game log, which is a log of everything that's happened in the world. So the way we actually interact with this is in this box here, we can issue instructions or ask questions, and that will then go through the semantic kernel to ultimately use AI to answer any questions that a user has or a GM has, or to even manipulate the state of the world. So to give a quick example, so we can say, what are their likes and dislikes? Oh, are you kidding me? Sorry, absolutely typical. Yes, not entirely sure why it's going wrong. Very sorry. Aha, sorry. Okay. So you can see you've asked the question what are their likes or dislikes. So it is gone away and figured out the answer to the question. So StreetF likes eating, sleeping, having a pet dog, dislikes not knowing parents and cats. So you can kind of see how this could be useful for, at the moment we only have sort of like a relatively small list of known facts about the player, but certainly I've been in campaigns that have lasted years and years, so this could grow to a list of hundreds and hundreds of entries and allow you to quickly search for it and answer questions quite quickly. So to quickly go through how semantic kernel actually goes to achieving this, the first thing we need is an actual kernel itself. So the kernel is sort of the heart of the entire program. So it's what contains the various AI services. So you can attach AI services such as we've got text completion here. So this is an example of building up a very simple kernel that will be used for text completion functions. And text completion was part of the service that just answered that question. We then add a client on to the completion service for it to interact with. So at the moment we're using the Azure OpenAI client, but it will also work with the OpenAI project as well. You can use either endpoints interchangeably. And then we also add memory. So memory is how our system holds information that the kernel will need. And at the moment, this is a simple memory, so it's volatile. So when this pretty much, the memory disappears when the kernel is destroyed, but you can have it persistent, so we have integration with, we've got a JDBC driver, so you can integrate with databases. We also have integration with Azure Cognitive Search that will also store data for you. So this is an example of building a simple kernel. The actual kernel we'll be using today is slightly more complex because I've configured a few things like retry options, and we also, depending on the scenario, choose different models depending on what we'll be doing later. But either way, that's our kernel. So then once we have a kernel built, we then need to add skills into it. So the skill we just used was the query world skill. So skills can either be written in native code, so Java, and I'll show some examples of that later, or it can be a prompt that gets rendered and then sent off into the AI for it to then generate its response to. So again, the prompt we just used was this one, of answer a question purely based on the set known facts. Give it a few prompts about don't make things up, and also provide some support for your how you came to your conclusion. So we then give a few examples of how to go about answering questions here. This is a technique sort of called few-shot prompting, where you give it a few examples of how to do something before you go about and ask it. So then we come to the actual sort of meat of the prompt, which is a list of known facts about the player. We template in the player name, some facts, again, the player name again, and then the question that came from the user that then gets gets put in, and then it generates its answer. So I think if we go look at the terminal, we should see that, yep, it's gone away and rendered our prompt, and then put in some information, some facts that it can use to answer the question about loves and hates, because I asked it what their likes and dislikes. So it's come away with 5 facts that are related to likes and dislikes, given it to the AI that then went away and generated the answer that was, again, gave the likes, dislikes, and then gave it supporting evidence as to how it came to that conclusion. So the information that got placed in by the templating engine, we have a context, and we just set variables on that context. So here we can see you set the facts, and we've set the player name. So then when we go away and invoke our function, that's already on the context. It gets pulled out, put into the template, and rendered and sent off. So another thing that is interesting about the prompt that just got rendered is that we only gave it 5 facts, even though if you actually look at the list of facts, there are far more. And the 5 facts it gave were very close already to being about likes and dislikes. So how did we know to pick those 5 facts? So this uses a feature of the memory. So, like I said, the memory can already contain, can either be persistent and go to the database, or it can go to Azure Cognitive Search. And it has a function called embeddings, where when you save information into the memory, it generates an embedding to go with it. Sure many of you have seen this, that embeddings are very large numerical vectors that represent a piece of text. And the general concept is that to the distance between two vectors is a measure of the relatedness of that information. So if you find things that are close together, those are sort of typically about the same topic. So we took all of the facts about our player, we saved them into our memory. At that time, the embeddings were automatically generated. Then when we came along and asked our question, we did a search. And into the search, we put our query, so what the likes and dislikes. And at that point, it went off, found the 5 most relevant facts. I've asked it to give me 5. It found them, did a pretty good job, found the likes and dislikes, and then allowed it to. Brought them back, so they then got put into that facts variable and then rendered. So another kind of interesting way that I've used this skill, text, is the character generation. So here, we've got a function that generates characters for the world, but before it generates the character, it goes off, does that search, finds similarities again, and provides that information as context into the generation prompt. So using this, not only will characters you generate just be sort of very generic RPG characters, these will be characters that will be very specifically defined, be very specifically for your world and part of your world. So here you can see that it's taken the information about StreetF and figured out that, it's incorporated the fact that Lyra's inherited her father's strength and height, but also his cowardice. So again, yeah, you can see how you could go generate content that is very much about your world. Also, one thing that's interesting about the embeddings is that it can sort of make interpretations such as, when we previously talked about likes and dislikes, it was kind of very on the nose in that we already have loves and hates in here. Sorry. But it can talk about similarities, such as it will figure out that when you're talking about religion, goddess is a related word to that area. So it should now figure out that, yes, this person is religious, yep, they're religious, and they're a devout follower of the goddess of the sky. So it can understand that similarity. So to now go to the next thing we can do, which is we can issue instructions to manipulate our world. So we can say StreetF gives Gren a potion. So if we run this, and we notice that currently StreetF has 3 potions. And if we run it, it takes a while because this does actually involve several round trips to the AI to figure this out. But now he's down to 2 potions. We've got a player log that is StreetF gave Gren a potion, and we have a log in the world that the same happened. So enter the players and the world's log. In the player, so Gren now has an extra potion that they didn't have before, and again, they also have an entry into the world log. So no, I've not actually coded any explicit method of transferring items between 2 characters in this world. I've given it very simple functionality, and it has figured out from the simple functionality how to go about achieving this process of transferring items. So it's doing this via something called a planner. So as I say, the planner takes a sequence, a menu of functions, and using that menu of functions, figures out how to go about achieving a goal. So here we can see that it basically issues a statement of generate an XML step, a plan step by step. We define some sort of rules about how to go about generating this content. So this is just sort of a standard prompt that's included in Semantic Kernel. We then give it a series of function descriptions, that is descriptions of the functions, the inputs and outputs from them. We then ask it, achieve a goal, and it then comes back with a bit of XML that says, well, this sequence of instructions are what I think you should do to achieve this goal. So we can see here what we got. We had all our functions: add item to inventory, add log events, apply damage, can cast player, can player cast skill. And we also have some rules of the world that I've been kind of building up over time. And then we had our goal of streetf gives Gren a potion. So it decided that the sequence it needed to do was remove item from inventory. Good. Add a log entry. Great. Add a log entry to, so that was add a log entry to the world, add a log entry to the player, add item to the new person's inventory, and then add another log event to their inventory. So again, I've not explicitly told it how to transfer items, it's figured it out for itself. So the final one I can do is, terrible at using a keyboard. Actually, no, it's on that character. Yep. Right, so Grencast laser on streetf. So this is going to, again, go to the planner, look at all of its options and try and figure out how, what do I need to do in order to achieve that. So first thing it says is Gren can cast laser. I need to figure out a way of tidying up this text a bit, but effectively what it's doing there is it's following a rule of the world that I've defined, which is before a spell is cast, place an entry into the world log that states if casters are able to cast that spell. So you can see here that I'm defining these rules, and these rules get put into the planner's instructions, and it, again, figures out how to follow those rules on the fly. So yeah, it says yes, we can cast a spell, and it does 10 damage. streetf's new health is now 0, and streetf is now unconscious. So hopefully if we go to look at streetf, yep, indeed his health is now 0. So we can now go and let's say Gren thinks streetf has not had enough, gives it another shot. So now what should happen is it should now go be able to figure out that, yes, Gren has no spells left. So you can see how you can use this over time to sort of figure out when people are cheating and stuff and using more spells than they have. And yeah, they've used more spells and gone down to negative spell numbers. So yeah. Hopefully you can kind of see how you can build up world rules over time that define your world and allow you to assist you finding players using items they don't have in their inventory or spells they don't have, etc. Okay.
Anybody has questions?
Sure.
Yes. Yeah, I know you. Let's go there first.
So, maybe not a too serious question, but one of the world rules I noticed was a weapon is not a potion. Is there a funny story behind that?
Can you just repeat the question, please?
Sorry, yeah. So one of the question was, one of the world rules I had is that, was it a potion is not a weapon or a weapon is not a potion? A weapon is not a potion. What did it try to do? It tried to invoke one of the skills that was about damage, and it tried to treat weapon damage and treat it as a potion. I forget exactly what it did, but yes, it got the planner got mixed up, and it tried to use the potion as a weapon. So, yeah.
Yes, Sean.
Regarding these rules,
seems like a very powerful way to apply to many problem sets. But I'm trying to understand how you're using the semantic kernel model.
Show the prompt. So the question is how the rules are involved in the communication with OpenAI.
Yeah.
Okay.
At a deeper level, if you don't mind.
Yeah. It's not that deep. We just get those rules and put in the prompt.
Oh, okay.
And then OpenAI figures out. Hopefully they get it right.
So maybe a better question would be, given those, so the rules that you've had make a lot of sense, and you're doing a lot of reduce by one, add this to this, give this, and that's very, that makes a lot of sense. Have you tried to stretch the limits of these rules at all to be like more?
If we have tried to stress, how would you describe stressing rules here?
Stretch.
Stretch, yes.
So you're talking about making sort of more grander rules, like that would define.
Like don't kill a human, use self-defense only, like
Stuff like that,
3 rules of
maybe
robots.
stretching the numbers a little bit, like the numerics, more than just add one, take away one. You know, just wondering if you've ever stress tested.
No, we've not expanded this. I mean, we're still sort of in quite early stages of this. I mean, there's a fair amount of functionality that I'm still wanting to add onto this.
So one thing that we know is that OpenAI is not great with numbers. We were looking at that earlier. That's why there is actually a native skill in the semantic kernels where we do math, basic math. So when we don't tell OpenAI to add this number with that number, we tell OpenAI, hey, you have to add these 2 numbers. Here's a native skill that actually runs code to make that addition, right? And that is a way to overcome whatever OpenAI is non-deterministic, especially with numbers. So there are other native skills that can be implemented to avoid and be more deterministic in the system. And that's how you can just use OpenAI to more like treat the data, give you the more specific plan, and then execute that in the actual code. Other questions? Yes?
So I remember I implemented some stuff about agents back when the paper everybody probably read came out, and one of the problems I had, or one of the things I had a big problem was if it generated actions that didn't quite match the grammar that I was trying to get it to generate. What happens here? Is it just like a retry? Do you try to guess what it meant? What is it?
So the question is about if the plan doesn't, it's not right.
If the grammar of the plan is not quite what the code tries to do.
Yeah.
Okay.
Yeah. So this is using the text completion. So you can use the chat completion, where you can have a bit of a back and forth with it. So if it generates something a bit wrong, you can come back to it and say, you didn't get that right, give it another go. You can do that. So I have also at times done sort of cleaning up, because sometimes, for instance, typically it loves putting double braces into JSON for some reason. And I have done some sort of manual cleanup steps of cleaning up JSON with, when it does that kind of thing. So yeah, it does happen, but so far I've been doing it with sort of manual cleanup on that. But, yeah.
So one thing that we realized eventually that like the planner is powerful, but yes, sometimes the plan is not perfect. So one idea, we have not implemented it here, but is just like in databases, you can ask for the execution plan of the database before the query is actually executed. We could have something here where you ask the planner of the semantic kernel to expose the plan, you show that to the user or the operator or whatever, and then they hit approve, and then it executes, right? Or you don't approve, try again. So that interface can be added into any application, any system, any UI, but that's more part of the application development than the semantic kernel itself. But yes, it's one idea. So yeah, thank you so much. Appreciate it.